Kia ora Year 11 and 12. This video is going to go through the basic rules for differentiating polynomials. I'm going to start with the rules and a simple example for each, and then there'll be about 8 practice questions for you to try.
Hello.
Okay, so the first rule is our simple one. If f of x is equal to x to the power of n, then the derivative, or gradient function, is given by taking the power, bringing it down, putting it out in front of the x, and reducing the power by 1. For example, if f of x is equal to x to the power of 7, f dash of x is equal to 7x to the power of 6. The next rule is that if my function is just a constant, then the gradient function is 0. So the best way to think about this is by looking at the graph. So if I've got f of x equals 2, that is the graph of a horizontal straight line here at x equals 2, and its slope is 0 for any x value. The last rule is just a development of the first one up there, and that is that if f of x is equal to a constant times x to the power of n, then I proceed as before. I bring down the n, stick it in next to the a, times those two numbers together, and reduce the power by 1. For example, if f of x is equal to 2 times x to the power of 7, f dash of x is going to be equal to 14x to the power of 6. Okay, so now for the examples. Right, as usual, if you can pause the video when each slide comes up and have a go at them, and then we'll go through them. So this first one is going to have a gradient function, f dash of x, right, which is going to be 10x plus 10. So notice that that 2 has gone down to an invisible number 1. So it's just 10x plus 10. Now, just a note on notation, I could have written that as y equals 5x squared plus 10x. If it's written as y equals something, then we usually use this notation, dy by dx, for my gradient function. They mean exactly the same thing. It's just convention that when I start with y, I write the gradient function as dy by dx. When I start with f of x, I write it as f dash of x. If you want to read about the interesting historical stuff about how that happened, there's a good page in the New Lake book talking about Newton and Leibniz. Okay, the next one is where people start to come a little bit unstuck, and that's because we have got fractions going on. But the rules apply just as usual. So f dash of x here is going to be equal to 2 times 3/4 x plus, well, this is x to the power of 1, so the gradient function is just going to be 1/5 minus 7x to the power of 6 over 6. So we need to clean that up. We get 6 over 4, which is the same as 3 over 2x plus 1/5 minus 7/6 of x to the power of 6. If you find these fractions really confusing, a good thing to do is to rewrite them like this. Let me just put a wee line here, so that's up there. So you can rewrite the function so that the fraction is sitting out the front. Right? So we have 3/4 x squared plus 1/5 x minus 1/6 x to the power of 7. Like that. Okay, and that should help. Okay, on to the next couple. Right, another fraction one. So I'm going to do the rewriting thing in here. So rewrite y to make it easier not to go wrong. You won't have to do this for very long. Okay, so there it is. So dy by dx is equal to 18 over 5. Right, I'm taking the 9 and I'm timesing it in by the 2 in the numerator, plus 24 over 2 x to the power of 7. Oops, I've lost my x in the last one, so that should be 18/5 of x to the power of 8 plus 49 over 6 x to the power of 6th, and this is a constant, so that differentiates to 0. Now I need to clean up a little bit of stuff in here because I don't want to leave 24 over 2. Right, don't change these into decimals. That is mathematical ugliness. Just leave them as lovely little fractions, but simplify them as far down as you can. Remember, the FD button on your calculator is a cool thing to use if you really can't stand simplifying fractions. Now that's got to have a 6 there. There we go. Okay, so that's a couple of practice ones with fractions. Now the next one is me sneakily getting you to do some algebra practice in the middle of calculus. So we're going to expand out the quadratic because we can't differentiate it as it is. So we're going to go y equals 2x squared plus 6x minus 4x minus 12. So y equals 2x squared plus 2x minus 12. dy by dx, which is the same as f dash of x, is equal to 4x plus 2. Next one, right, more expanding practice. So f of x is equal to x times, right, let's expand this out. Well, this is x plus 3 times x plus 3. So it's x times x squared plus 6x plus 9. Now expanding out again, f of x is x cubed plus 6x squared plus 9x. So f dash of x is equal to 3x squared plus 12x plus 9. Just leave it like that. Don't try and factorise it back or anything fancy. That's all good. Next one has got you expanding a cubic. So it doesn't matter which two you start with. I'm going to expand the back two brackets first. So we'll have x minus 1 times x squared minus 2x minus 4x plus 8. So that gives me f of x is x minus 1 times x squared minus 6x plus 8. So that equals, first I'm going to times everything through by x, so x cubed minus 6x squared plus 8x, and now everything through by negative 1, minus x squared plus 6x minus 8. Now I'm going to collect up like terms. I get x cubed minus 7x squared plus 14x minus 8. Now finally I'm ready to differentiate that. I'm running out of space, so I'm going to do it up in here. Just box that off there. So we get f dash of x for this function up in here. We've done all the hard work, right? The differentiation is easy now. So 3x squared minus 14x plus 14. Right, remembering that the constant differentiates to nothing. All this does on the graph is it just shifts my function up or down. In this case it shifts it down by 8 units. Right, two more examples to finish off. Right, so practice again, simplifying, expanding and simplifying. So 3 times x squared minus 14x plus 49. Right, be careful here, we've got a minus, so it's going to be minus 4x plus 24 for that times that. So expanding out again, 3x squared minus 42x plus 147 minus 4x plus 24 equals 3x squared minus 46x plus, let's see, 171. So dy by dx is equal to 6x minus 46. Right, last one. We've got y equals 3x squared times, right, expanding this out, we get x squared minus 2x plus 1. So y equals 3x to the power of 4 minus 6x cubed plus 3x squared. Now differentiating, dy by dx, which is the gradient function. Okay, so it's exactly the same as f dash of x, is 12 x cubed minus 18x squared plus 6x. Okay, the examples in New Lake on page 17 are quite similar to these, so you should have completed all of those by now, but if you haven't, go and finish those off. Thanks for watching.